So our next unit it looks at systems of equations. So systems of equations builds on our previous unit where we looked at the equations of straight lines. So not only did we look at how we can identify the slope, the y-intercept, sometimes even the x-intercept from those equations of straight lines, but we also looked at how to graph those equations of straight lines using a variety of different methods. So now we're going to look at systems of equations. So systems of equations is two lines that we graph on the same set of axes that we are going to then interpret based on the context of the question. So let's start by looking at example 1. So the example 1 looks at the cost to rent two different halls. So let's say you are planning on renting a hall for prom or renting a hall for a wedding or a buck and doe or whatever it happens to be. We're going to then look at the cost of those rentals for those two different halls. So we're going to describe what we call the point of intersection. So that's where the two lines will cross each other. And then we're going to identify for which hall will it be cheaper. So for how many guests should you invite in order for the hall to be cheaper than the other. And we're going to explain that based on the graph. So example A looks at hall C and hall D. Hall C is the red dotted line, hall D is the blue dotted line. So what we want to do is we want to identify this point of intersection. So that's where the two lines intersect or where they cross. They cross at a point of 150, 4,500. So we need to identify the coordinates. So the x value in our coordinate refers to our x-axis, which is the number of guests, so 150 guests. The y value in our coordinate is 4,500, so that refers to our y-axis, which is the cost in dollars. So this would be $4,500. So our point of intersection states that for 150 guests, both halls will cost $4,500. $4,500, an extra zero there. Okay, so it doesn't matter which hall you end up renting. If you have exactly 150 people, they both are going to cost you $4,500. So what happens before that point of intersection and what happens after that point of intersection? So if we have less than 150 guests, so if we have 149 guests and below, which hall is going to be cheaper? Well, we can see based on the graph, so before the point of intersection, hall C is lower than hall D, so hall C will be cheaper. And if we have more than 150 guests, so after our point of intersection, which line is lower? It's the blue line, which refers to hall D. So hall D is cheaper. So now let's use that same information to interpret the example B. So again, we have two halls, the rental cost of those. Hall E is the purple dotted line. Hall F is the green dotted line. Here's our point of intersection. The coordinates of our point of intersection is 240 and then 18,000. The x-coordinate, so 240, refers to the number of guests, so 240 guests, and the y value of the coordinate refers to our y-axis, which is the cost in dollars, so $18,000. So we can say the point of intersection states that for 240 guests, both halls will cost $18,000. So again, we're going to determine what happens before our point of intersection and what happens after our point of intersection. So if we have less than 240 guests, we're looking at what happens before that point of intersection, and which line is lower, that's Hall E. So Hall E is cheaper. And if we have more than 240 guests, what happens after our point of intersection, which line is lower? It's the green one, which is Hall F. So Hall F is cheaper. Apologies for this. There we go. Okay. So now that we've looked at those two examples, let's look at another context. So an example with a different context for the question. So example number 2, we're going to refer to this graph right here, which is the cost of pizzas. So the graph represents the cost to produce and sell pizzas. So if you happen to work at like Domino's or Pizza Hut or whatever it happens to be, this would be something that refers to that. So graph A, which is our red dotted line, refers to how much it costs to produce pizzas. So if you are selling 0 pizzas, it's still going to cost you $200 a day. Maybe that includes your rent, your hydro, whatever it happens to be, the cost of materials that you have on hand, the cost to pay employees, all of that takes into consideration. Graph B represents the income for your pizzas. So how much are you selling each pizza for? So obviously if you don't sell any pizzas, you're not going to make any money. And obviously it goes up from there. So now we're going to describe our point of intersection. So what does that mean in the context of our question? Well, same thing, we're going to look at identifying our variables or our values in our coordinate. So our x value refers to our x coordinate or x axis, which is the number of pizzas, so 30 pizzas. And our y value refers to the y axis, which is the cost and income, and that's in dollar amount, so $350. So that tells us when we sell and make 30 pizzas, the cost and income will be $350. So it's going to cost you $350 to make those 30 pizzas, and you're going to earn $350. So what that ends up being is your break-even point. So the cost is the same as your income. So you cancel each other out. So we want to know then how many pizzas must we sell in order to make a profit. So when is our income line greater than our cost line? Well, remember our blue line is our income line and our red line is our cost line. So when is like I said, our income line greater than our cost line? Well, that happens after our point of intersection. So that tells us, when we're going to assume that we're going to only sell whole pizzas, we're not going to have slices at our store. That means that after 31 pizzas, so after 30 pizzas, so if we sell 31 pizzas, we are going to make a profit. And how do we know that? Well, we can look at our graph and we know that our income line is greater than our profit line, our cost line. It's greater than our cost line. And we can even say after our point of intersection. You'll notice I'm using POI It's just easier to write POI than point of intersection, so save yourself some time in that respect. So that's very helpful information to know. So if you own your own business, where is your break-even point? So where are you going to make money versus losing money? So whether that is if you're mowing lawns, for example, how many lawns do you have to make to cover the cost of the gas, perhaps, that you're putting in, or the cost of your the lawnmower itself? All things to consider. So when we are modeling word problems, so this is what we had done in those first two examples. So we're taking real life situations and we are using the concept of straight lines to interpret that information. That's what we call modeling word problems. And we do that when we're doing this using systems of linear equations. We first have to define our variables. So sometimes the equations aren't going to be given to you, like they were in example 1 and B, or even the graphs might not be given to you. So you're going to have to do your own graphing and your own interpretation of those equations. So in order to create your own system of linear equations, you must first define your variables. And we do that by using let statements. So let X represent, or let Y represent, and so on. And once you've defined your variables, then you can create each of your equations. And sometimes creating those equations can be the hardest part of the question. So once you master that, you're golden, because we already know how to graph our straight lines based on the methods we learned in our previous unit. So we can find the y-intercept and then use the slope, or we can identify the y-intercept and the x-intercepts and then connect those 2 points. There's lots of different strategies that you can use. So there are two types of linear system problems that we're going to encounter in this course. We're going to look at the two types of linear systems that can be modeled. So the first is when you have a single scenario, but you have it under different conditions. So an example of this, and I apologize for the typos in this question, Jason weighs 6 kilograms, less than twice a Bill's weight. If the sum of their weights is 102 kilograms, how much does each person weigh? So the first thing we want to do is identify our variables. And to keep it simple in this question, we're going to let J represent Jason's weight. And you can even identify the units. So Jason's weight in kilograms. And we're using J because it's this first letter of Jason's name. And then we're going to let Bill, or let B, represent Bill's weight. And again, we're using kilograms, in kilograms. Okay, so I've identified my variables. Now I'm going to create my equations. And like I said, creating the equations can be the trickiest part. So we're going to, in this example, we're going to look at each sentence individually and try to come up with an equation for each sentence. So Jason weighs 6 kilograms less than twice a Bill's weight. So Jason is 6 kilograms less. So the weight of Jason minus 6 kilograms is equal to twice a Bill's weight. So 2 times B. That makes sense? All right, now let's take a look at the second equation. So the second sentence says, if the sum of their weights is 102 kilograms. Okay, so that tells us that if I add up Jason's weight and Bill's weight, it should add up to 102 kilograms. Yeah. Okay, so now I have two equations based on this question. I'm not going to look at solving the equations today. We're just going to look at interpreting those. All right, so the second scenario that you might have is when you have different scenarios but they're under the same condition or similar conditions. So what that looks like is if we're comparing two different things, but the concept of those things refers to similar conditions. So Carl's towing charges $80 plus 22 cents per kilometer. Bev's towing charges $70 plus 30 cents per kilometer. Write a system of linear equations to represent this problem. Which towing company would you use? So let's start by identifying our variables. So let's let C represent the total cost. And then let's let K, for example. Let's let K represent the number of kilometers that you're towing. Okay, so C is going to represent the total cost. K is going to represent the number of kilometers towed. So we're going to come up with two equations, one for Carl and one for Bev. So the equations are going to look very similar, but we're going to write them for each of those two different scenarios. So for example, Carl. So the total cost is equal to $80. So I'm going to get charged $80 no matter what. So $80 plus, and then 22 cents per kilometer. So 0.22K. So 22 cents per kilometer plus my $80. So now let's write a similar equation for Bev's. So my total cost, if I go with Bev, is going to be $70. So regardless of how far I'm towing, I still have to pay them $70 plus 30 cents, so 0.3 times K. So you'll notice that the equations are similar in format, and this is that scenario there. Okay. So once we've looked at the different ways that you might be able to create equations, so whether we have different scenarios but we're coming up with similar equations, or whether we have the same scenario but we're coming up with different equations, we're going to now look at combining that with what we did for example 1 and 2. So example 3, Paris Fitness Club charges a flat fee of $25 per month plus $5 per visit. Panthers Fitness charges a flat fee of $35 per month plus $3 per visit. For how many visits per month is the total cost the same for both clubs? So step number 1 is to create an equation for each of these fitness clubs, but we have to define our variables first, so that's really important. So when you're creating your own equations, you have to define your variables. So similar to what we did above, we are going to let C represent the total cost, and we're looking at $25 per month, so the total cost per month. And we are going to, let's say, let V represent the number of visits at the gym, or in a month. Let's say that, the number of visits in each month. Okay, so now we're going to create an equation for the Paris Fitness Club, and we're going to create an equation for the Panthers Fitness Club. So the total cost for Paris will be $25 per month, so you're charging $25 regardless of whether you go to the gym or not, and plus $5 per visit, so 5 times V. For Panthers Fitness Club, the total cost per month, they're going to charge you $35 per month regardless if you go or not, plus $3 per visit, so 3 times V. Now when we're looking at these equations here, we can think about, well, what does this mean? So when we looked at the equation of a straight line, for example, the equation of a straight line is y equals mx plus b, where the m is our slope and our b is our y-intercept. We'll notice that these equations these are backwards, right? So this would be our mx right here, and this right here is our b. So the number in front of your letter, your variable, is your slope, and the number all by itself is your y-intercept. So when I am sketching this graph or sketching these lines, this is my y-intercept. So for Paris, I am going to go up to 25, which is right here, and this is my y-intercept there. So my y-axis is going up by tens, and my x-axis is going up by twos. But if you even look even further at these little individual lines, these are actually going up by fives, and these are actually going up by ones. But I've only labeled every other line to make our lives a little bit simpler in that respect. So in our question, the x is actually v. So I can go ahead and change this x to a v to represent the letters that I used. And my y is going to be my c, so the total cost. And I'm going to label my x and y axis. So my v refers to the number of visits per month. And my y, or my c in this case, refers to the, I'm going to try to write sideways. It's going to be difficult. The total cost per month. It's not terrible. Okay. And this is in dollars. Okay. So now I can use my slope to come up with the other points on my line. So remember, when I'm looking at slope, if it's not given to me as a fraction, then I can write it as a fraction. So 5 is the same as 5 over 1. So remember, it's rise over run. So I'm going up 5 units over 1 unit, up 5 units over 1 unit, up 5 units over 1 unit. And I'm going to keep going all the way up. Again, until I run out of room on my graph. Because I don't know where my point of intersection will be. It might happen early in my graph, or it might happen further up in my graph. So the more points that I do, the easier it's going to be. So now I'm going to connect these. Now I'm going to have to start a little bit further from my x-axis or my y-axis in order to draw my straight line. If you're doing this on paper, you're going to start right at your y-axis. So you're going to be using a ruler, ideally. You can draw your arrow on this side to show that it goes forever. I'm not going to be able to go this direction because I can't go negative times, right? That's not a possibility. So I could try just erasing this portion right here. There we go. Okay. So this is my line for Paris. So I'm going to label this. If you're doing it at home, you might use different colors for each graph. I only have access to a blue pen in this program that I'm using, so please bear with me for that. Okay, so the next thing I'm going to do is graph my equation for Panthers. So Panthers, I start with my y-intercept. So this is my b here. So 35. So I'm going to come up and plot a point at 35 right there. And this right here is this is my mx. So my slope is 3. which is the same as 3 over 1. And remember, this is rise over run. So for every unit I'm going up, I'm going up 3 units for every unit that I'm going across. Now, my graph is goes up by 5s. And going up by 3s might be a little tricky to graph. So what I can also use is the concept of equivalent fractions. So I want to go up by a value of 5. So maybe I want to go up by 10s or 15s or whatever. So right now I want to find an equivalent fraction for 3 over 1, where our numerator is a multiple of 5. So what do I have to multiply 3 by in order for it to also be a multiple of 5? Well, why don't we start by multiplying it by 5? So remember, whatever I do to the numerator, I do to the denominator. So this is going to be 15 over 5. So 15 over 5, like I said, will simplify back down to 3 over 1, but this is easier. This is an easier slope for us to sketch on our graph with our scale. So if you're going up by 1s already, it's not going to matter what your slope is. But like I said, in this case, I'm going up by 5s. So I want to have my slope. It's easy, like I said, it's easier to sketch my graph if my slope is now going to be a multiple of 5. So what this tells us that I'm going to go up 15 units for every 5 units that I'm going across. So I'm going up 15, so 5, 10, 15, but I'm going to cross 5. 1, 2, 3, 4, 5, right there. Happens to be the same line, same point as my first one. All right, so I'm going to remember that. Then I'm going to go up 5, 10, 15, across 1, 2, 3, 4, 5, right there. So remember, this right here is what is our other point, right there. Okay, and then again, same thing. I'm going to go up 15, so 5, 10, 15, and go over 5. 1, 2, 3, 4, 5. Can I go up one more? Yes. 5, 10, 15, over 5. 1, 2, 3, 4, 5. So same slope, but it's easier for me to sketch it on my graph in multiples of 5. So now I'm going to connect these points. If you have any questions about this, please let me know, okay? So send me an email, put a post on the discussion board. So this is my Panthers line. So this is supposed to be my point of intersection right here. If you're using a ruler, your lines are going to be much nicer than mine are. So keep that in mind. Let me see if I can. That's a little bit better if I move my line. All right, so here's my point of intersection right there. So what are the coordinates of this point? Well, the coordinates of this point is 5, so I've gone over 5, and I'm going up, look at that, right at 50. So this tells us that if I go 5 visits per month, well then my cost, doesn't matter which gym I go to, is going to be the same at $50. So find the point of intersection, it's right there. And I don't need to describe my point of intersection in words. It's not asking for that, but I can easily identify that. So if I'm going 5 times a month, each gym is going to cost me $50. So that's important to know. So I've just taken what I've learned from my previous unit to sketch these graphs, and I've quickly identified that point of intersection. So I hope that helps you to first of all start by interpreting graphs of linear systems. Please post any questions you might have in the um, uh, discussion tab, and I'll look forward to teaching you more.